Hi guys, today we're going to be looking at a question on electrostatics. Three small identical metal spheres, P, S and T, on insulated stands are initially neutral. They are then charged to carry these charges. Negative 15 times 10 to the power negative 9 coulombs, Q, which is unknown, and then 2 times 10 to the power negative 9 coulombs respectively, as shown in the diagram below. The charged spheres are brought together so that all three charges touch each other at the same time and are then separated. The charge on each sphere after the separation is negative 3 times 10 to the power negative 9 coulombs. Question 7.1. Calculate the value of charge Q. Since we have the net charge after they have all come in contact and separated, we can take that value, being Q net, is equal to Q1 plus Q2 plus Q3 all over 3. We can then plug in our values, and when we rearrange, we should get that Q is equal to 4 times 10 to the power negative 9 coulombs. Question 7.2. Draw the electric field pattern associated with the charged spheres S and T after they have separated and return to their original positions. After they have separated, they both have the charge of negative 3 times 10 to the power negative 9, therefore both negatively charged. So all your field lines should be pointing towards the charges. This is because the electrons move from positive to negative, therefore they're moving towards the negative. The spheres, each with the new charge of negative 3 times 10 to the power 9 coulombs, are now placed at points on the x-axis and the y-axis, as shown in the diagram below, with sphere P at the origin, this being the diagram. Question 7.3. State Coulomb's law in words. So Coulomb's law is just another definition that you can learn and easy 2 marks. The definition is that the magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitude of their charges and inversely proportional to the square distance between them. Calculate the magnitude of the Question 7.4. Net electrostatic force acting on sphere P. I'm going to do this on the next slide so you can see it more clearly. So this is question 7.4. To do this, we first need to get the force of S on P and the force of T on P. We can do that by using this equation over here. So for FSP, we sub in our values, K being a constant that we know, and the distance between them being 0,1 meters. If we plug all of that into the calculator, we should get 8.1 times 10 to the power negative 6 newtons. And this is a force acting downwards. For FTP, we can do the same, and the distance between those is 0.3 meters. And if we plug all of this into the calculator, we should get 9 times 10 to the power negative 7 newtons to the left. Since we want to calculate the net force, and this is essentially a triangle, we can use Pythagoras and say that F net is equal to the square root of force FSP squared plus the force FTP squared. And when we sub in our values and plug our answer into the calculator, the values, we should get 8.15 times 10 to the power negative 6 newtons. Question 7.5. Calculate the net electric field at the origin due to charges S and T. To calculate that, we can use this equation over here, using the force we have and the charge to calculate the electrostatic force. We then know our force total, and we divide it by the charge, and we should get 2,72 times 10 to the power 3 newtons per coulomb. Question 7.6. One of the charged spheres experiences a very small increase in mass after it is charged initially. Question 7.6.1. Which sphere, P or T, experiences this very small increase in mass? Since we know that sphere P has a negative charge, it therefore has gained more electrons. Therefore, it has increased in mass. Therefore, the sphere is P. Question 7.6.2. Calculate the increase in mass by the sphere in question 7.6.1. I'm going to do this on a new page so you can see the answer more clearly. So, to calculate the mass gained, we can say that the number of moles of the electrons is equal to the charge over the charge of an electron. We therefore know that the charge is negative 15 times 10 to the power negative 9. The charge of an electron being negative 1,6 times 10 to the power negative 19. And if we plug that into the calculator, we get 9.38 times 10 to the power 10. To calculate the mass gained, we say that the amount of moles of the electron, so mass, is the moles of the electron times the mass of an electron, which the mass of the electron being a given value on the formula sheet. And when we calculate all of this, we get 8.55 times 10 to the power negative 20 kilograms. And that's all for this question. Thank you.